Welcome back to the channel. It's the Earth Science Classroom. This video is on environmental science and air pollution, and we're going to discuss a topic called incomplete combustion and discuss the term combustion, discuss the term incomplete combustion, and the effect of incomplete combustion on our environment. This is the Earth Science Classroom. Welcome back to the channel. There are 6 types of combustion, which include spontaneous, explosive, slow, complete, rapid, and incomplete. Now, in general, combustion involves a fuel and an oxidant. In this case, we're talking about coal, so looking at coal as the fuel, and the oxidant in the atmosphere would be oxygen. And this reaction between the fuel and the oxidant is exothermic and redox chemical reaction. It also includes a physical change, which is the mass transfer of elements and atoms, and produces various products such as water, CO2, NO2, and SO2 in the chemical reaction. So therefore, the different types of combustion, except for incomplete, involve the formation of certain products through the chemical reactions to the fuel, in this case coal or hydrocarbons, and the oxidant, in this case oxygen. And this topic is applicable to environmental science and air pollution and our society in general, because we use combustion to produce energy for our society. Coal is used as a baseline fuel to produce energy, in this case electricity and heat, and currently produces about 35% of the world's energy requirement in the form of electricity. As with other types of combustion, incomplete combustion has its own type of characteristics and environments in which it forms. Now, generally, it is the lack of converting all the fuel to CO2 or H2O, and it produces various byproducts from these chemical reactions whereby the oxidant, in this case oxygen, is deficient or there's too much fuel, and it produces certain toxins and hazardous gases and products due to the unburnt fractions of the fuel. In many cases, the color of the flame caused by the combustion can indicate whether the combustion is complete or incomplete. Generally, the more yellow or orange the flame, it's going to indicate an incomplete combustion environment whereby the fuel is not adequately reacting with the oxygen to form the CO2 or H2O or even SO3 or NO2 molecules. So as a result of incomplete combustion, what you have is various environmentally hazardous products produced both outdoors and indoors wherever the combustion is occurring. The first one is CO, or carbon monoxide, which can be toxic in large concentrations in certain environments, and if there's not enough oxygen, then you just produce the unburnt carbon or coal, which returns into soot, which is the fine black particles of around 2.5 micrometers, or we call particulate matter. The next product is the polycyclic aromatic hydrocarbons, or PAHs for short, which includes formaldehyde and acetaldehyde, benzene, and various dioxins. And these products are all a result of the reduction in temperature during combustion, or the lack of fuel or too much fuel, or the lack of oxygen, the oxidant, in the chemical reaction process. In addition to carbon and the incomplete combustion of coal, you also have the incomplete combustion with nitrogen in terms of ammonia, or NH3, which can turn into, through incomplete combustion, N2 plus water. And with sulfur, there is a regular combustion of SO3, but then with incomplete combustion, it produces more SO2 or sulfur dioxide, which can be harmful in the environment. As discussed before, incomplete combustion of mostly carbon-based coal as a fuel or nitrogen or sulfur fuel products can produce environmentally toxic pollutants that can affect the environment both indoors and outdoors. For example, the PAHs and the hydrocarbons will contaminate water sources. They're carcinogenic. When they add to particulate matter, they become toxic and a severe air pollutant. Then you have the SO2, which with complete is SO3, which is toxic by itself, but incomplete SO2 can add into producing acid rain, and also with the addition of hydrogen produce sulfuric acid, H2SO4, which can cause severe damage to the environment. Then you have the nitrogen, N2 or NO, which is nitric oxide, which can form ground level ozone and tropospheric smog, and also add into particulate matter to create acid rain as a secondary pollutant. Then we have the soot, or the fine particles, the PM2.5, which can also contribute to poor air quality and health issues for humans and the environment. Then you have the formaldehyde, which is CH2O, which is a VOC, or volatile organic compound, which also can add into producing smog or photochemical smog. Acetaldehyde is a VOC as well and can produce photochemical smog. Benzene, which is a very powerful air pollutant and very dangerous, is a VOC and can also produce SOA, which is secondary organic aerosols. Then we have the dioxins, which are basically horrible for the environment. They are POPs, which is persistent organic pollutants, very hard to break down in nature, and they'll contaminate both water and soil layers and produce severe environmental pollution. This is the Earth Science Classroom. Thank you for watching the video. I really appreciate it. And if you get a chance to like and subscribe, that stuff really helps the channel. Thank you so much. And see you again in a future video.